Continuing with Module 1 and function notation, we are going to discuss the domain and range of a function. The domain is a set of all values that the independent variable can take on. So it's the collection of all the possible input variables or input values that will produce real values for f of x, our function. The range of the function is a set of all values that the function assumes. So it's the set of all values that come out of our function. Recall that we are not able to divide by 0. It produces an undefined value. And we are also not able to take the square root of a negative number. So when we're trying to find the domain of a function, we need to look at these cases and figure out what values of x cannot go into the function. Remember that the domain is a set of all x values or input values that are able to go into the function and produce real values as our output. So what is the domain of f of x for f of x is equal to the square root of 3x minus 1? Okay, we have 3x minus 1 is all under the square root sign. We know that anything that goes under the square root must be positive or equal to 0. So it has to be greater than or equal to 0 because we cannot take the square root of a negative number. And if we solve for x, we're adding 1 to both sides of the equation or bringing the negative 1 to the other side, we get 3x is greater than or equal to 1. And lastly, to solve for x, we divide both sides of the equation by 3, and we find that x is greater than or equal to 1/3. So our domain is that x can be greater than any real number greater than or equal to 1/3. We can write this in set notation, where our domain D is defined by the set of all x values that belong to the set of real numbers such that x is greater than or equal to 1/3. So like I said, this definition is called set notation. We have that x is an element. This fancy R is for the set of real numbers. And the last thing I want to point out is this vertical bar, which means such that. And set notation is something that doesn't necessarily come that naturally. It requires some practice and also reading lots of mathematical notation to become comfortable with it. So this is one way that we can denote our domain, so that and notice here we have curly brackets to denote the full set of numbers that x can take on. Another way that we can write our domain is using an interval. So we know that x can take on values as low as 1/3 and all the way up to infinity. So we have our start value and our stop. You'll notice that my start value uses a square bracket because x can be equal to 1/3 but not less than. And because it's able to be equal to 1/3, we use a square bracket, whereas it can go up to infinity, but it's actually impossible for a number to actually equal infinity because infinity is never a defined value. There's always a value larger. So we use a round bracket to mean that it cannot equal infinity. So now we've looked at expressing a domain in set notation as well as interval notation for the function f of x is equal to the square root of 3x minus 1. Now we're going to do the same thing, so find the domain for the function f of x is equal to 1 over x minus 3. Remember, we can't divide by 0, and because we are unable to divide by 0, it means that our denominator of our function cannot equal 0. If we solve for x, we find that x cannot equal positive 3. Now we can express the domain using set notation. So our domain is a set of real numbers. So x belongs to the real numbers such that x cannot equal 3. Okay, so it's all real numbers except for x is equal to positive 3. And we can also write this as interval notation. The only thing with interval notation is that there's two different intervals that we need to consider. So the interval from negative infinity up to 3 and positive 3 up to positive infinity. And we want the combination of these two sets, which we write as a union. Notice here in interval notation, all of my brackets are round brackets because we don't want to include the value of x equals 3 in any of the sets because our domain is such that x cannot equal 3. And we've already described above why we cannot have square brackets on positive or negative infinity. So and lastly, we look at the function f of x is equal to 3x plus 1, and we want to describe the domain, which is all the values that we are able to put into this function. We can see there's no square root, there's no denominator, and we can actually input any real number x into this function and get a real output. So our domain is actually just a set of all real numbers. And we can write that an interval notation from negative to positive infinity. So that's all real numbers. So given a graph in the xy plane, if you want to determine whether or not the graph is a function, we're able to use a vertical line test. So by definition, every input, so every x value, only produces a single output value. And so we can only have one y value for each value of x. So if we take a vertical line, you should be able to, and I often just use my pen or a ruler, but I'm going to show you sort of what you do. You can slide your pen or ruler across the function, and your graph is a function as long as for each value of x, your vertical line only crosses the function or the graph once. So we can see in part B with this sideways sort of parabola, we're able to draw a vertical line. So for one value of x, you can see here it has two values of y, so not a unique value of y. Therefore, it is not a function. Whereas the first one was a function because each value of x has only one output.